Here we're going to take a look at Advanced Math Lesson 10.2, Product of Powers Properties. So there are a few rules here that we're going to talk about. So the first one is the product of powers property. To multiply powers with the same base, we add their exponents. So here we have 4 squared times 4 cubed. Since it's a product of powers multiplying, we keep the base and add those exponents. 2 plus 3 is 5, so 4 to the 5th power. The power of a power property. So to find a power of a power, multiply the exponent. So when we have a power to a second power, or to another power, we multiply the exponent. So here, 6 times 3 is 18. So the answer here would be 4 to the 18th. Power of a product. To find a power of a product, find the power of each factor and multiply. So here, 3 times 2 to the 5th is like 3 to the 5th times 2 to the 5th. That exponent is applied to every factor there inside the parentheses. Let's take a look at some examples. So here with this first one, 6 squared times 6 to the 4th. This is that product of powers property. So this is like saying 6 to the 2nd times 6 to the 4th. We add those exponents. So I'm going to write it like this up here so we can remember. So 2 plus 4 is 6. So this is like 6 to the 6th power. You go ahead and try numbers 2 and 3, and then come back and we'll try them together. With these, again, this is negative 1/2 to the 3rd times negative 1/2 to the 6th. Since we have the same base, we can add these exponents. 3 plus 6 is 9, so this is negative 1/2 to the 9th power. On number 3, this one's a little tricky. We have z times z to the 12th. Well, we see here that the first z does not have an exponent. When there is no exponent given, it's understood to be a 1. So z to the 1st times z to the 12th, we can add those exponents to get z to the 13th power. And we can kind of see this as, I know I would have z times 12 more z's, and we could then have 13 z's if we showed our repeated multiplication. Now, on number 4, a power of a power. So we're raising the original power to a new power. This is when we multiply those exponents. So 4 times 3 is 12. So this is 4 to the 12th power. We can see that because that would be like 4 times 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 4. We can see that when we do this 3 times, we would have 4 to the 12th power. You go ahead and give numbers 5 and 6 a try. Here with number 5, we have y to the 2nd to the 4th. Again, 2 times 4 is 8, so this is y to the 8th power. On number 6, we have negative 4 cubed to the 2nd power. Again, negative 4, and then we can multiply those exponents. 3 times 2 is 3 times 2 is 6. So negative 4 to the 6th power. With 7, 8, and 9, we have a power of a product property. So remember that we are going to use that exponent and apply it to everything in the parentheses. So 5y to the 4th is like 5 to the 4th, y to the 4th. Now, when we go to simplify this, we know that 5 to the 4th is 625. So our answer would be, our simplified expression would be 625 y to the 4th power. You go ahead and try number 8 and 9. With number 8, again, ab to the 5th power is a to the 5th, b to the 5th. The same thing with number 9. 0.5 mn to the 2nd is like 0.5 squared m squared n squared. we can simplify 0.5 squared to 0.25. So our simplified expression would be 0.25 m squared n squared.